Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about surveying. At ako ay may isang problem na inihanda para sa inyo guys na sa tingin ko ay makatutulong kung masusundan ninyo ang solution sa problem. Sapagkat sa pamamagitan nitong problem ito ay makikita nyo kung paano tayo mag-solve ng elements ng simple curvature at kung sakali ang isang element ay mabago, papaano natin sosolve ang bagong elements ng curvature. So our problem goes like this. Okay. So in the problem, we have a backtangent that has an azimuth of 45 degrees. It is intersected by a forward tangent having an azimuth of 10 degrees and connected by a 6-degree simple curvature. In letter A, if the stationing of the piece is at 1 plus 210, we are required to find all the elements of simple curve. And also, we are required to draw the simple curve showing the other elements. While in the second question, if it is required to change the position of the center of the curvature 15 meter closer to the vertex without changing the position of the PC and the PT, then we are required to find for the elements of the new simple curve. Kaya dito sa problem na ito, ano ay meron tayong given elements ng curve. Okay, and then from there, okay, we will be defining the other elements. At yung elements na sinasabi dito, yung direction ng tangents. At yung stationing ng PC at yung tinatawag nating uh, degree of curvature that will connect the two tangents. Let's start by drawing our direction of the tangent. Magsimula tayo dito sa tangent na ito. No? Assume natin na we have here our point. And then from this point, we try to draw the direction of the tangent by defining our azimuth of 45 degrees. So from here, ipakita natin yung kanyang azimuth. Ito halimbawa yung kanyang 45 degrees. And then a line that will connect this point to an azimuth of 45 degrees. Ito yung magiging direction ng ating back tangent. So let us imagine that here is our back tangent. And assuming natin na somewhere here, okay, it will be intersected by a forward tangent having an azimuth of 10 degrees. Kaya ipakita natin ito. Okay, from here, ipakita natin yung azimuth na 10 degrees. So from the south, we measure an angle of 10 degrees and then we connect, okay, it with a line starting from the point of tangency up to this direction. Okay, so this becomes our direction of the forward tangent. And assuming that somewhere here, ito yung ating tinatawag na point of tangency. Kaya yung ating initial point shall be defined by this point which shall serve as our PC, which is actually at station 1 plus 210. So somewhere here is our vertex and at the end, we have our point of tangency. Now, how are we going to show here our curvature? So the curvature will be drawn by establishing first our center, which can be drawn by drawing a perpendicular line through the PC. A line that is perpendicular to the back tangent through the PC. So ipakita natin ito. So that would establish our perpendicular line. Then starting from PC, mag-drawing tayo until we establish the position or the direct location of our center. So dito sa line ito, we will be able to establish where is the location of our center. Similarly, mula dito sa ating PT, okay, mag-drawing tayo ng perpendicular line and then the intersection of these two lines will serve as our center, yung gitna ng ating curvature. And let us imagine that this is our O. And then from here, makikita natin yung curvature, that the curvature will be drawn starting from PC, okay, towards the PT, in this direction. And then ang direction niya is papaganyan, Okay. Pakita natin ito, yung kanyang radius. Then here's our, curvature. Okay. So our curve now is shown here, having the elements that you have the PC, the back tangent, okay, the direction of our curvature. So this line will be our tangent line, the line that connects PC and the vertex. Similarly, the same is true with the line connecting our vertex and the PT. This is also our tangent distance. And this angle between the lines drawn from PC to PT towards the center will be our intersection angle defined by I. And that is also the same angle as the angle between the extension of the tangent line from here towards the forward tangent. So this is also our intersection angle. And so from here, after you have established our elements, so we can now start with our computation of the different elements by starting with the intersection angle. So we refer to this to intersection angle. Ano? And how do we get this intersection angle? The extension of this back tangent would also have the same angle as this 45 degrees measured from the south. Ano? So this angle will also be equal to 45 degrees. But because this angle is already 10 degrees, hence we can solve for our I as a difference between 45 and 10 degrees. Our I will be equal to 45 degrees here minus 10 degrees, and that our I is equal to 35 degrees. So after we have solved for our intersection angle, we are now ready to solve for our radius of the curvature. So we can now solve for the radius of the curvature, and that, our radius of the curvature is shown here, which can be solved by the formula, using of course the degree of the curvature, ano? Because we are given the degree of the curvature, therefore the radius can be found to be 1145.916 divided by the degree of curvature equal to 6. Now, if you're going to substitute the value of the degree of the curvature, okay, having a value equal to 6, therefore, the radius becomes equal to 190.986 meters. Now, we solved now for the next element and we consider here our tangent distance. We are actually locating this, solving for this tangent distance as shown in the figure. And how do we solve for this tangent distance? The tangent distance has the formula equal to the radius multiplied by the tangent of 1/2 of the intersection angle. And so if we are to substitute the values of the radius of the curvature, which is 190.986, and the central angle or the intersection angle of a computed value equal to 35 here, therefore our t becomes 190.986 multiplied by tangent of 35 over 2, which when simplified, will give us a value equal to 60.218 meters. So this value now is equal to 60.218 meters. Now, after we have solved for the tangent distance, so we can solve for the length of the curvature. And the length of the curvature is shown here by in our illustration, representing this arc length. And how can we compute this arc length? This can be computed by the formula equal to 20 multiplied by I divided by the degree of the curvature. So if you're going to substitute the I and D, therefore our length of curvature will be equal to 20 multiplied by 35 divided by 6 and giving us a value of 116.67. Now after we have computed here our length of the curvature, what shall we solve next? So we can solve here for the stationing of our PT, the stationing of this end of the curvature, PT. And how do we solve for the stationing of the PT? So we can solve for stationing of the PT by simply adding from the stationing of the PC the length of the curvature. So because we are given here the stationing of the PC, which is at 1 plus 210, and we have just computed the length of the curvature equal to 116.67, therefore our stationing of PT will be 1 plus 210 plus 116.67, giving us 1 plus 326.67. Now after we have solved for the PT, we can now solve for the length of the long chord. Okay, how do we define here the length of the long chord? It is actually the line that joins our PC and the PT. So this is our length of the long chord represented here by the symbol C. And how do we solve for this C? So the C can be taken by okay, the formula that C is equal to 2 times the radius multiplied by sine of 1/2 of the intersection angle or sine of I over 2, which when okay substituted with the value of R and I, so we can solve for the C, which is equal to okay 2 multiplied by 190.986 k times sine of 35 divided by 2, giving us a value for C equal to 114.86. Now after we have solved for k the value of C, so we can now solve for the middle ordinate. And what is this middle ordinate? Actually, that is the line between the long chord and the curvature measured along the line joining O and K, the vertex of the curvature. And so this is actually our middle ordinate as you would see here in the illustration. This line from this point up to that point. And how do we solve for that middle ordinate? If we're going to consider this figure, okay, in the figure, the intersection of the line joining the vertex and the O is given by the point F. And from there, okay, makikita natin now that this middle ordinate is actually the difference between this radius minus the distance, okay, from F to O. So that in here, our middle ordinate is actually our radius minus the line segment F and O. But what is this F sub O equal to? As you would see, kung titignan natin dito sa figure na ito, yung triangle na yan, ano? Okay, this F sub O actually is the adjacent side of this angle I over 2, considering this triangle. And this triangle is actually a right triangle. Actually, this triangle is a right triangle, having this angle as the right angle. And this distance PC to O is our okay, hypotenuse represented by okay, the radius R. Hence, we can solve for F sub O as that, okay, F sub O is equal to, okay, R times cosine of I over 2 in this illustration. Now, if we're going to substitute this F sub O or FO, the line segment FO in the formula, therefore our middle ordinate becomes equal to R minus R cosine of I over 2, which can be simplified by factoring out our R, and R can be and our middle ordinate can be taken as k the product of R multiplied by the quantity 1 minus cosine of I over 2. So that if the value of R and again this intersection angle is substituted, we can solve for the middle ordinate as 190.986 multiplied by 1 minus cosine of 35 over 2, giving us a value of M equal to 8.839 meters. So after that, we can now solve for what? For the external distance E. And what is our external distance? The external distance is actually the distance from the vertex to the curvature measured along this line joining from B to O. So kung makikita natin dito, ito yung ating kay yan, yung nakikita natin gumagalaw yun. Yung part nito, this is our kay external distance. So you can find that E actually from the figure is equal to kay this line segment VO minus the radius of the curvature. Di ba? But what is this VO equal to? Okay, yung VO can be taken using this triangle. This triangle that I am showing, okay, VPC to O, where okay, VO actually is the hypotenuse of the triangle having this angle as our right angle and this angle is as I over 2. Hence, B sub O will be equal to okay, R over cosine of I over 2. And if this will be substituted to this equation, our E becomes equal to R over cosine of I over 2 minus R. And if R will be substituted with the value, okay, our equation becomes 190 times or divided by cosine of 35 over 2 minus 190.986. That if this will be computed, okay, E will be equal to 9.283 meters. Now, pagkatapos nating masolve yung ating external distance A, ang kasunod nating sosolvin ay itong kay subchord C1 and C2. Now, para maunawaan natin ano ba itong subchord C1 and C2, let us now try to imagine ano ba yung naging composition ng ating simple curvature after we have identified its length. Ano? So, ipakita natin na itong ating simple curvature ay actually binubuo ng kay different full chords, ano? From along this point from PC to PT ay binubuo yan ng different stationings, ano? Nakikita natin dito. So ito yung mga station na nakita natin dito. Stationing 1, 2, 3, 4, 5, 6, 7, and the stationing PT. Ano? And this stationing na nakikita natin inside kay the curvature are all full station. They are all kay divisible by 20. And the first kay subchord C sub 1 ay mangyayari o magkakaroon kapag yung ating stationing ng PC ay not falling on kay a full station or not divisible by 20. Nagaya ng nakikita natin dito na stationing of 1 plus 210 which is not a full station. Hence, kay meron tayong C sub 1 which is actually the difference between what? Our first full station, our first full station and that stationing of the PC. At makikita natin yan, ano? Kung drawing natin yan, it's chord here, ano? Will be subtending an angle. Okay? Itong mga angle na ito sinasubtend to will be defined as the this, yung mga full station natin are the degree of curvature. And this okay, small length nito, yung ating subchord C sub 1, will be subtending a small angle called subangle. Di ba? So let us now try to define here, ano ba itong subchord C sub 1? So for subchord C sub 1, ito yung tinatawag nating, okay, itong line na ito na makita natin, okay, between the PC and the first full station. So if this will be our first full station, diba? So yun yung ating C sub 1. So sabihin, okay, the C sub 1 will be the first full station minus the stationing of the PC. Where the first full station is the stationing after the first station after PC that is divisible by 20. Hence, this will be our first full station. And that this our C sub 1 can be computed as okay, the first full station minus the stationing of the PC. That is equal to 1 plus 220 minus 1 plus 210, which give us a C sub 1 equal to 10 meters. So, ganoon din sa ating C sub 2, ano? Yung C sub 2 naman is actually kay this length, ano? Yun yung distance naman between the last full station and our stationing of the PT. And it will exist kay kung ang ating stationing of the PT is not falling at the full, is not actually divisible by 20. And because our stationing of the PT was computed at which is not divisible by 20, hence we shall have Kc sub 2. And C sub 2 actually K will be equal to what? The stationing of the PT minus the last full station. So ito yung ating tinatawag na last full station kung titingnan ano, yun yung part na ito. So if this will be substituted with the value, therefore our C sub 2 will be 1 plus 326.67 minus 1 plus 320. Kaya yung ating C sub 2 will be equal to 6.67 meters. Then after that, okay, how are we going to solve out for our sub-angles D sub 1 and D sub 2? Yung sub-angles natin na tinatawag dito are the angles subtended by the subchord C sub 1 and C sub 2. And okay, these angles, ano, yun yung angle na tinutukoy natin to. Ito yung D sub 1 na yun, makikita natin sa illustration. Diba? Samantalang yung D sub 2 naman, ito makikita natin dito, and that is our kay D sub 2. Ito makikita natin part na ito. And how do we solve for this D sub 1 and D sub 2? Okay, for D sub 1, okay, this is equal to okay, 2 times arc sine of C1 over okay, 2R, ano? Okay, and when the value is substituted, we shall have here our okay, D sub 1 to be 2 times arc sine of 10 okay, divided by 2 times 190.986. That if this will be substituted, our degree is equal to 3 degrees. Similarly, that can be taken, ano, sub-angle D sub 2 can be taken using the same okay, approach. That okay, our formula will be equal to okay, 2 sine or 2 arc sine of C sub 2 over 2R. That if the value will be substituted, our D sub 2 will be equal to 2 degrees. So that's our solution. Yun yung elements na pinapakita natin. Ano? Napuntahan natin yung second question. Yung second question sinasabi dito, it is required to change the position of the center of the curvature 15 meters closer to the vertex without changing the position of the PC and the PT. Determine the elements of the new simple curve. So sa konseptong ito, kay sinasabi na ito daw center na ito, ay ililipat natin ang pwesto at palalapitin natin doon sa vertex by moving it 15 meters closer along this direction. So ipakita natin yung mangyayari. Yun yung ating vertex, iginalaw natin. So if this will be 15 meters, okay, we will be finding, okay, the elements of the new curve with the condition that the position of the PC and the PT will remain unchanged. Sa makatwid, kung ito hindi mababago, therefore, makikita natin na yung ating radius of the curvature will be at the line, okay, the line that will be joining the new center and the PC, and the new center and that of the PT. This will be our new radius. Pwede natin siyang tawagin new radius, di ba? And that the angle that is subtended by the same arc, okay, by the arc, of course the arc will be changed also, but the position, ano, okay, by this new radius, ano, will be will become our new intersection angle. And if we shall be able to solve for our new intersection angle and our new radius of the curvature, then the elements of the new simple curvature can be solved. So let us solve now. Okay, first for this new radius. Paano ba natin masosolve yung new radius? Knowing that the center will be moved 15 meters from its original position towards the vertex. Therefore, masosolve natin yung ating okay, radius by considering the triangle PC, okay, V, and that O sub O. Dito muna tayo magsimula sa malaking triangle na ito na PC, V, and O sub O. At gusto kong ipakita itong triangle na ito. Ano? So, anong purpose ko dyan? Para ipakita ko that this angle will be equal to beta. And that beta, no, can be taken, okay, masosolve natin itong beta na yun because this beta can be solved using this triangle and knowing that the sum of all the interior angles of the triangle must be equal to, okay, 180. Hence, beta will be equal to, okay, 180 minus 90 minus 1 half of I. Sa makatwid, itong ating okay, beta will be 90 minus I over 2 na lang ang magiging resulta, di ba? So that this becomes equal to, okay, when substituted with the value of I over 2, which is 17.5, our beta will be equal to 62.5. Itong angle na yun. Ano? Now, considering this triangle P sub PC, O sub N and O sub O, this triangle, from here up to this point and up to that point, okay? So, kulayan natin itong triangle na ito. You can find that in the triangle, okay, there are elements that are already known, like this angle, which is equal to 1 half of I, and the movement of the center, which is 15. And so you have here, okay, a triangle having two sides given and the included angle. And therefore, the third side is represented here by this R sub n can be taken by the use of the cosine law. So we can solve therefore for R sub n using cosine law, where the cosine law states that the square of that side or the opposite of the included angle I sub I over 2 is equal to the sum of the squares of the two other sides, R square and this 15 square, minus twice the product of R, the two sides, R and 15, and the cosine of the included angle I sub O over 2. That if R and I sub O are substituted with in the formula, we can compute for the value of R sub n. And R sub n now is equal to 176.74 meters. Now after we have computed for this R sub n, we need only to know what will be the new center of central angle for us to be able to, okay, compute the new elements of the simple curvature. But how do we solve for this IN or this new central angle? Now let us try to consider here, okay, this triangle PVN. V and O sub n. From this triangle, P sub C, V and O sub n. So maybe I can have it colored in this manner. So kinulayan natin yan and let us represent that okay, triangle. So in the triangle, we are already known the following. Okay, we know that this angle is angle beta, which is already computed at 62.5. And we have computed for R sub n. And that R sub n is equal to 176.74. And because PC will remain at the same position, okay, therefore, this distance, okay, V to PC will be our T. And therefore, this triangle will be a triangle having, okay, at two known sides and one, okay, angle known. Di ba? And therefore, we can compute for the other elements by using sine law. So from here, we can compute for okay sine law, okay, because we are given r sub n. We are also given here our t. Equation becomes equal to 60.218 represented here by t. Okay, divided by sine of 1/2 of the new intersection angle. This angle is proportional to r sub n, which is this one. Okay, divided by sine of the opposite angle, which is beta, and that is equal to 62.5. And so from here, masosolve natin itong I sub n of 35.1817 degrees. So pagkatapos nating masolve itong dalawang elements, which are the very, very important elements in a simple curvature, okay, all the rest, all the rest, the elements of the new simple curvature can be computed using the same approach as presented earlier. Kaya sana sa pamagitan nitong sample problem na ipinakita ko sa inyo guys ay makatutulong sa inyo para ah, ma-solve yung bagong elements ng curvature, lalong-lalo na kapag ang isa sa mga elements nito ay nabago. Kaya guys, sana ay patuloy niyo ako subaybayan sa ginagawa nating discussions sa pamamagitan ng pag-subscribe sa ating channel at kung sakali na may mga kaibigan ka, mga kailangan ng ganitong klase ng discussions, maaari niyo itong share sa kanila so that they will be notified of these lectures. Once again, thank you very much for watching.